So it's about 0.528. Actually, it looks better up here. So I am not calibrated. Right now it's appearing larger than what it should be. Most likely because this is 1.5 inches, so there is some geometric magnification. But that's okay. I can calibrate this. There's this icon up here to the top to adjust for geometric calibration. If I know what the correct length is, I can type that in and just say 0.5 inches and hit set. So now the dimensions are accurate. So that's one of the measuring tools. We also have this one that is sort of a, kind of like a vernier caliper, that it's going to show me a real-time measurement as I extend it out. I'm a little crooked there, but let me see if I can do better. So you can use that tool as well for measuring dimensions. This is another tool that we just added to the software that can work very much like the optical comparator that you would use on film, where you have your circles of different dimensions. So you can set whatever dimension you want. Let's say you're looking for flaws down to 15 thousandths of an inch. Anything greater than 15 thousandths of an inch would be rejectable. You can set it to 15 thousandths of an inch. And if I had any indications, in the software, if I wanted to measure that, I could put that there. And that 1 T-hole is larger than 15 thousandths of an inch. You can use it for an optical comparator to do dimensional measurements. You can choose the pitch, which would control how many thousandths of an inch you can increase the size of it just by pressing the up and down arrow key on your keyboard. So it's a really nice function, something that we added to the software. But we also have, as an option, wall thickness measuring tools, which as long as I calibrated my software to a dimensional dimension, I can now use this thickness measuring tool for the wall and just draw a line across that. And it would give me my dimensional measurement right here in that little window. It's 0.175 inches for the wall thickness. Another nice feature we have is for thicknesses. I mean, of course, ultrasonics is going to be the most accurate for wall thickness measurements, right? But you can use radiography to kind of see if you're in the ballpark for wall thickness. So what you would have to do is set up a step wedge of known dimensions of that particular alloy that you're trying to radiograph. So what I can do is start setting samples. So I'm just going to put one right here on the 0.18 and tell the software this is 0.18 inches in thickness, and then set that for estimation. And I can start stepping up. The more data you give the measuring tool, the more accurate it's going to be. So it's 0.37 inches. We'll do a couple more. 0.62. Say 0.87. And then that last one, 1.5. Okay, then I can close that out. So now I can choose this icon and just place it anywhere on the part. And now it's giving me an estimated thickness of that material. So this being darker should be a thinner material over there. So 0.837 inches, 0.433. So a really valuable tool to have. You could try the thicker areas, which are about 1.12 inches. And again, these are estimations, just to see if you're within the ballpark. But it would be really good for corrosion detection in the wall. You could kind of estimate how much thickness you are losing or eroding in that wall. And to do some of the other features for process controls. So this is an example of a phantom that we use for digital radiography, DR technologies. So I can use the software to measure the spatial resolution on this duplex wire gauge. All I have to do is just draw a line across it, and the software is going to do all the measuring of the percentage of space in between the wires, and then it would actually come up with your spatial resolution right there in that window. It would also display it on the screen up there. And then I was mentioning earlier CNR, SNR measuring tools. CNR is typically measured on your 4T. We have a general CNR measuring tool. You're going to place one in the hole, one outside. You're able to adjust the size of that square. Maybe I want to make it just a little bit bigger, just for a better average. And then it does all the math for you. So it calculates your CNR directly on the software. Really nice feature. We also have this one that will measure contrast sensitivity. So it still gives me CNR, but also CS, which is contrast sensitivity, which is something ASTM 2698 and 2737 require us to have in the software. And then to measure SNR on this DDA image, we have this tool that measures signal level and signal to noise ratio. Again, remember, the higher the SNR, the better your image quality is going to be. Let's get that one over here. And then another nice feature that we have is what we call auto calibration. So once I have my tool set in place, I could save that as a template. Come down to auto calibration, save annotation template, and then let's pretend that I just took another shot of the same image, or it's the next day. I'm doing my daily shot for day number 2. Since I saved that template to the software, I can go ahead and apply that with the auto calibration, and it's going to place all the tools back where they belong. So that kind of helps make your job a little bit easier when you're starting your shift. We're working on more options with that. I need a new microphone.
Les pedimos disculpas, necesitamos reiniciar todo el equipamiento nuevamente. En las imágenes que se están viendo hay unas líneas que no corresponden, entonces para evitar cualquier confusión preferimos reiniciar el equipamiento nuevamente e iniciar la charla en óptimas condiciones. Les pedimos que nos aguarden unos minutos, por favor. Bueno, les pedimos nuevamente disculpas y ya estamos en condiciones de poder comenzar nuevamente con la segunda parte de la jornada. James, your turn.
Thank you. Yeah, this isn't working again. Thank you very much. So I switched over. This is going to be can you guys hear me? Okay. Switching over to the next PowerPoint presentation. This is about artificial intelligence, or what we call our assisted defect recognition in radiographic testing. So a lot of people think when they see FUJIFILM, they think cameras or film for photography. We do a lot more than just photography, of course. We do a lot in the medical industry, non-destructive testing industry. So we've been using a lot of our existing technologies in medical to help with non-destructive testing industries as well. So we've been doing a lot of screening for AI with welding radiographs, looking for particular flaws in welds, porosity, incomplete fusion, lack of penetration, and then also wall thickness, which is for corrosion. We've been working with AI on that. So again, these are our core technologies from FUJIFILM. So you can see we do a variety more than just non-destructive testing. Like I said, a little bit with imaging for photography, medical industry or healthcare, MRI, CTs, two-dimensional radiographs, and computed radiography. Also with bioengineering or biosciences, even some displays, your phones, laptop computers, some of that is actually made by FUJIFILM as well. And then printers, printing. So a little bit of everything. We had to diversify. If we just stuck to film cameras, we would probably be out of business. So now we have digital cameras and all the other technologies. So even in photography, we've made massive improvements in photography. Remember the first digital cameras that came out didn't have the best spatial resolution. Like if you zoom in, you could see the pixels, didn't look that great. But now we have cameras with much higher resolution, up over 100 megapixels for spatial resolution. This is actually an example of the first computed radiography system used in the medical industry, which you can see we've come a long ways. That was a very large system, but that was the very first one of its kind. That was the first CR system used in medical. So again, the main purpose was to reduce the amount of dose to the patient to make it faster. Less radiation on your body is good. And then we just exceeded from there, or progressed from there. So that was, back in the 80s. We also developed picture archiving and communication systems for medical industries. So that's where hospitals can store all their radiographic images. They can take a radiograph from another hospital and have it displayed at another, as long as they were connected to the PACS system. And in 2018, in the medical industry, we started to use AI to help the radiologist or the doctor in diagnosing or finding, medical problems in the body or inconsistencies. And that was called RELI. It's a collective intelligent AI technology creating new values collaborations with AI and humans. So we have image enhancement, where the AI can actually enhance the image to make it more visible to the radiologist to see the differences in the density. And then segmentation and labeling is more where that's where the software is going to look at individual parts of the body and look for any abnormalities. And it was able to detect any abnormalities in the body and flag it. And then detection and measurement as well. So it would look at, it would detect and quantify suspicious lesions in the medical images. So in non-destructive testing, we thought this would be another good way to go to help the level 2 inspectors or level 3s to do their job. So here's just a video example of the AI working in the medical industry, where it's just picking out certain areas of the body, looking for lesions. So it had a very good detection rate compared to what the human was able to detect. So it's still up to the doctor to make a call on what that is and if that's life-threatening. The AI is not going to tell you if, or it's not going to diagnose what it is. So we wanted to use that technology for non-destructive testing. I know in the United States and in Japan, we have a shortage of level 2 inspectors. In the United States, a lot of the, we call them baby boomers, which is my father's generation. A lot of the workforce is retiring, and there's not a lot of younger people getting into the NDT industry. So there's a shortage in the United States. So to kind of help alleviate some of the shortage issues, we started to develop the AI to help assist the humans to make them more efficient at doing their job and to also help not miss any indications. So it's a pretty interesting study that they did in Japan to show how their workforce is starting to diminish on level 2s. So that's a challenge, right? So we want to take that same technology from the medical industry and help the level 2s in the non-destructive testing industry. So the software can enhance the image quality. So the AI is going to be able to optimize the image to better suit your eyes for visibility or probability of detections. Segmentation and labeling, that's where it's going to start to pick out. You'll see over on the right side, screening AI, all these little squares that pop up, those are indications that it did find. And then detection and measurement. So for wall thickness AI, it's actually going to be able to do all the measurements for you on the wall thickness. And you could set the threshold of where to flag when you see an area that's too thin. I've got a couple videos to show you on that. But we're currently in the stage where we are teaching the AI with all the different indications. So it takes a lot of samples of different pipes, different parts, different castings. And we're trying to train the AI what these indications are. And it will learn what the indications are. And it's very accurate. We've done studies. Actually, it was an MAI study where they had 3 level 3 inspectors from one of the major foundries or casting facilities that the 3 different level 3s were looking at images. And sometimes you're not always going to get the same result from 3 different inspectors. Sometimes there's a variance there, right? It's just human nature. The detectability of the flaws in the humans was about 85% accurate between the 3 inspectors. And with the AI, it was depending on, which one was it? It was I believe it was 95 to 98% accurate. I think the numbers are coming up on another slide. So again, this is not here to replace the inspector. This is not to take the job of a level 2. It's there to assist you. Like I said, at Fuji, we don't want that liability of saying something is good and saying if it's bad. It's just there to help you. It's going to make your job more efficient. And this technology, it's going to work with our CR scanner that's already existing. It's going to work with our DDA images. We do have customers that are taking their film and turning it into a digital radiograph. We actually do sell a film digitizer to where it would scan your existing film and create a digital image off of it. So all those different modalities would be able to work with the AI. Nice thing about going with the film digitizer as well is once you digitize all your film, you have that stored on a separate hard drive or on a server, or the cloud. So that's your archiving, and you could sell your film, right? The price of silver is pretty expensive. So there are companies out there that will buy the film off of you and reclaim the silver. So sometimes those film digitizers can pay for themselves really quickly. So the screening AI is going to be for welding and casting, discontinuities or defect detections, and then wall thickness AI is going to be for corrosion detection. So here's just a video of the AI, the screening AI, looking for weld indications. So all the little red squares that you see, those are just the rounded indications, porosity, slag. You are able to adjust the threshold on how big of a flaw you want it to find or how small. So you can see there are some that aren't showing up. That's just because they had it set at a different threshold. But even the linear indications will show up in a different color. And again, it's just there to detect it. So you look at those areas and then you evaluate if it's good or bad. And it will actually label each of the indications. It will give you the X and Y location of it. That's your pixel location, the maximum length, and then also the defect type as well. And then the next column that you're not seeing to the right, that's where you would click if it's acceptable, rejectable, or if it's an artifact. So it's always good to have a second set of eyes to help you sometimes. Okay. And really what the AI is looking at is pixel value. You know, it's looking for consistency in the welds. Of course, you're going to have variance in the weld, but it's looking for the really drastic changes in pixel value. That's how it's able to detect it. And it's able to know the exact positioning of that indication. It even gives, like I said, the address, the length, the pixel value average, or pixel value mean. So it can measure length, the area, the gray value or pixel value mean, the distance between indications, and then the total number of indications that were found in that weld. So there's a lot in that weld, a lot of porosity. So yeah, to develop all this data and to make the AI more accurate, we had to do a huge number of training data. So that's multiple images and training the AI. Here is porosity, here is slag, here's tungsten inclusions or incomplete penetration, lack of fusion. Eventually the AI learns it and you're able to use it from there on out. There was a question asked by someone yesterday that we were displaying the technology, and the question was, am I going to have to teach the AI on what the indications are? And I just heard back from our software developers, and they said, no, they're doing all that development for you. So when it is implemented, it's going to be able to detect those indications automatically. You're not going to have to spend the time to teach it. It should already be operational. Now, if it makes a mistake and it's calling, let's say, slag porosity, and you know that it is slag and not porosity, you can train it or retrain it that no, this is slag, and then it'll learn even more. It's always learning. So yeah, this was the numbers I was looking for earlier. So this is what EB weld testing on titanium, pipe welding with steel, and then wheel welding with steel. So TPR is the true positive rate. So with the AI, we got about a 92% accuracy on that with the AI, which was better than humans. Humans were in the mid 80 percentage range. Pipe welding, slag inclusions, 90% true positive rate. And then gas holes or porosity, 99%. I remember 2 years ago, Fuji was developing AI for casting inspections, and they tested it on me, seeing if it made me any faster and more accurate. And so I started looking at images without ADR and felt like I did a pretty good inspection on it. And then when I applied the ADR, it found a couple indications that I missed. They were acceptable indications, but I didn't detect them. The ADR did. So it's pretty interesting to see that, how much more accurate it was. So yeah, screening AI can detect indications that are not easy by conventional AI for some reasons. So yeah, dissimilar metals, sometimes it has a hard time with that. So it shows a steep gradient of gray value across the welding direction, making it harder to see the defects. But it will learn over time as you work with it. And then even with linear shape where there's dissimilar metals, it can have a hard time with it. So for wall thickness AI, again, this is used more for corrosion detection in pipes. It's really good for oil and gas industry. So we've collaborated mostly in Japan with other oil and gas companies to start training the AI. So we are currently working on that, making really good progress with it. Nice thing about that is it's actually going to know what the dimensional measurements of those walls are. So it's going to be able to detect anything below that. Here's a video example of that. Just got to press play. So right now the software is reading it, screening the image. And now it detected where the walls are. And then you can draw the square over what you want to measure. And then it's automatically giving you those dimensional measurements and pointing out what the thickest and the thinnest area of the wall thickness is. And you can set the threshold of what would be rejectable. So you can see that it is putting annotations on the screen where it's thin. So you can set that threshold on the AI software. If I didn't have the AI, I would have to look at it visually and then start making dimensional measurements. So this will really help speed up your production, your process. So yeah, it's really measuring gray values. It's able to detect the wall just by different pixel values in the profile. And of course, it can struggle if the weld is, if there's a lot of different geometries to the weld or it's not consistent. That's where the human would have to step in and make that dimensional measurement manually. But over time, it should get better at detecting those as well. But some of the data on that has shown us the inspection time using ADR or AI. We were able to reduce the time of inspection, a 54% reduction in time on that. So again, time is money, right? So the more efficient you are at inspecting, the more you can inspect, the more money you can make. And then also fluctuations of measurements and thickness. So 58% reduction in that in standard deviation compared to the human, compared to the AI. So AI was more accurate than the human was. Some of the future steps that we're working on too, right now currently it's in development, the AI. We're pretty much finished with the welding defects or discontinuities. The AI has learned that. We're working on the corrosion part of that AI right now, and that's well underway. So we're going to be finalizing it in the first quarter of 2026, and then it should be available the second quarter of 2026, so about in April. this technology will be available. And something else we're developing is for like your daily checks, process controls. You can actually have the AI evaluate and let you know if there's any degradation in system performance. So it's going to read the image and then automatically start measuring spatial resolution without you really having to do anything else on it. It's even capable of detecting the 2T hole on penetrometers, measuring CNR and SNR. So this is something that was requested by a lot of our customers in the United States, is to have the AI do that for the inspectors in the beginning of the shift. And that's all I have on the AI. Is there any questions about it or ADR? Now we got to the question section faster than I thought, but. No questions on AI? I don't. I don't have that data. So basically, go ahead.
Sí, quería preguntar cuántas indicaciones falsas fueron encontradas por la AI.
This isn't working again. How many samples? That I don't know. I would have to ask our software developers. I know with the casting inspections, it was well over 1,000 images that it took. But it's already been developed, so it's not something that you would have to do. It's already going to be programmed to work with welding and corrosion and castings. But thank you for your question.
¿Alguna otra pregunta?
Does this software come with actualizations when it's improved, or the version that we get once we buy the product is the one that we're always going to be working with?
Ooh, excellent question as well. No, we do upgrade anytime there's a revision to the software. Our salesmen or account managers will come in and they can update it for you to the latest version. Absolutely. Thank you. Oh, there's one.
Tengo otra pregunta. ¿El soporte que brinda la IA viene incorporada con el software del panel flexible?
There we go. Number 2.
¿El soporte que brinda la IA viene incorporada con el software del panel flexible?
I'm losing you. It's broken up. It's really hard to hear it. Let me try this. Here we go. That's better.
¿El soporte que brinda la IA viene incorporado con el software del panel flexible?
Yes.
Es un modo opcional.
Yep. It is optional. Yeah, it's not included with it. It's an optional, additional pricing. I'm not in sales, so I don't know the exact pricing on that. I think we're working on figuring that out.
Sí, yo te quiero consultar si el módulo de inteligencia artificial ya tiene incluidos los criterios de aceptación de los códigos de construcción.
Another good question. No, that's still going to be up to the level 2, the acceptance criteria. We don't want that liability of making the software accept or reject. That may be something in the future, but right now we want to leave that up to the inspectors. But you can set the thresholds on corrosion measurements to where it's going to detect it, let you know if it's below the minimum wall thickness. But we're not able to load the acceptance criteria standards. And even those standards or acceptance criteria, they get updated, here and there and changed. So that would be more for us to keep up on that, all the changes involved. So for now, no, it's not an option.
¿Hay alguna otra pregunta?
I'm sorry, I did. Yeah, I did. Yeah. No other questions?
No more questions.
Okay, I have a question for you guys. This is, I appreciate you having me here. It's been a pleasure meeting some of you and talking with you. Can I get a selfie of me with everyone in the background? It's a big deal for me, I'm sorry. But, let's see. Oop. Okay. Say whiskey. Okay. Gracias. Thank you
Muchas
very much.
gracias, James. Le damos un fuerte aplauso. Thank you very much.
Thank you very much.
Y para cerrar esta jornada, vamos a invitar nuevamente a María Florencia Osa, que se acerque al escenario, y a Pablo González Tahuá. Y les pedimos que nos hagan un cierre final. Muchas gracias.
Ya cerrando la jornada, queda agradecer. Bueno, primero creo que estuvo bien, estuvo muy buena. Nosotros siempre lo que buscamos en estas jornadas, además de que entendemos que hay un propósito comercial, también queremos que se transmitan cuestiones técnicas, ¿sí? Y bueno, y ahí lo pudimos ver en el tema de las resoluciones espaciales, de algunos cálculos, que la verdad que vienen bien para ir tomando los elementos que necesitamos para ir avanzando en esta tecnología. Así que, bueno, nosotros seguiremos con estas actividades, estén atentos también, están invitados a proponer charlas, ¿sí? O temáticas especiales, o mismo empresas que quieran mostrar, bueno, en esta clase de eventos, ¿no? Después sabemos que tenemos los otros, tenemos el Corende como un congreso, ¿no? A otro nivel, pero estas charlas tienen que ir siendo quizá más cotidianas, me parece. Así que, nada, eso. Tendrán novedades nuestras para el año que viene. Seguimos bueno, nosotros, como saben, seguimos trabajando. Hoy mismo hay exámenes que se están dando allá en el famoso edificio 9. Ahí está Aurelio, Sergio, Alejandro tomando. Así que todo eso saben que nosotros seguimos en actividad. El año que viene, marzo, curso de evaluación visual nivel 2, ¿sí? Multisector, como se le dice. Lo largaremos y estaremos avanzando también en el esquema de certificación. La calificación Face Array, que ya vamos, sé que lo vengo diciendo hace bastante, pero los hechos van como atrasándolo un poquito, pedimos disculpas por eso, pero bueno, pronto la vamos a tener acá. Estamos haciendo algunas preparaciones ahí con algo de termografía, ¿sí? Internas, como para ir preparando el terreno, así que sépanlo. Y bueno, nada, les agradecemos a todos, en especial, bueno, le agradezco a todo el equipo, a Julia, siempre los chicos de auditorio con todo el nivel, a Eva también, que estos eventos son todo preparación de ella, a todo el departamento de ensayo no destructivo, a todos los compañeros, colegas, a todos los operadores, ¿sí? Con los que nos cruzamos todos los días, ARO nuevamente por estar acá, siempre acompañando. Y al equipo de Fuji también, muchas gracias, ¿sí? Así que bueno, las esperamos en la próxima, ¿sí? Gracias.
Bueno, de nuestra parte, nuevamente agradecerles por haberse acercado, por haber compartido este rato con nosotros. Esperamos que les haya resultado provechoso el seminario. No quiero dejar de agradecerle a Martín Soriano y a su equipo por el trabajo de interpretación. Es un tema difícil, al que no están acostumbrados seguramente, porque es hiper específico. Pero bueno, muchas gracias porque siempre trabajan con mucho profesionalismo. Bueno, nuevamente agradecerle a Jim, que vino a darnos este seminario. Esperamos que haya nuevas oportunidades en el futuro de encarar o el tema de los paneles flexibles, que tuvo muchas inquietudes, u otros temas que podamos ir incorporando. En los próximos días van a estar recibiendo de nuestra parte el certificado de asistencia. Si en el plazo de una semana no lo recibieron, por favor comuníquense con nosotros y verificamos tener sus datos correctamente. Y también van a estar recibiendo de nuestra parte una encuesta que les agradeceríamos se tomaran unos minutos para responder, donde también esperamos que nos puedan proponer nuevos temas que les interesen para organizar más eventos como este, si Dios quiere, en colaboración con nuestros amigos del INTI. Así que bueno, les agradezco y espero volver a verlos pronto.
Bueno, damos por cerrada esta jornada. Les agradecemos que hayan participado y que nos hayan acompañado y les deseamos que tengan un muy lindo día. Muchas gracias.